Students, at the previous video we have discussed about the 1 and many to 1 functions. Now we are discussing about other two types of the functions, that is the onto, that is called the surjective, and into functions. So what is onto function? Onto function means a function if a to b is onto if each element of codomain must have each element of codomain must have a pre-image at set A. That is, if each element of the codomain must have a pre-image, then we can say that is onto. That means each and every element of the set B must have a pre-image at the set A. How we will do this one? See the arrow diagram here. This is the set A, this is the set B. If those are the elements of set A and those are the elements of set B, then actually all the elements of set B will be occupied by the elements of set A. No any elements of set B will be left here. That's why I am drawing the arrow diagram here. Like this. Just see, no any elements are left at the set B. At the previous functions, some elements can be left there which were not associating with the set A, and some elements of the set A. But here, all the elements of set B will be associated with the elements of set A. Here, the codomain equals to the range. What is the codomain? That is the range here. At the previous functions, the codomains were the subsets of the range. But here the codomain is equal to the range. That means here onto means the total set A is going and sitting on the set B. No any elements are being left here. You can say the superimposing on the set B, like that. So codomain is equals to the range. Here no any proper analytical definition is there like the previous two functions, and also no any proper graphical representation is also there. The number of functions that is number of functions of onto, that is cardinality of A is M, cardinality of B is N, where N is greater than M, then the number is quite big. Actually NCR means the combination. Class 11 students, you will just read after some days the permutations and combination, and class 12 students knows this one. Just keep in mind number of onto functions will be this. Now how to check? For example number 3, checking. Onto function, I am taking one example, that is fx equals to say 3 minus 4x, where a, b, or you can say where f real numbers to real numbers. F is defined on the real numbers here, and fx equals to 3 minus 4x. So how to check this one? Let y equals to 3 minus 4x. That means we are taking one image, that is y of 3 minus 4x. Now from here we can say x equals to 3 minus y by 4. 3 minus y by 4. Now fx equals to 3 minus 4 into 3 minus y by 4. So from here we are getting 3 minus 3 plus y, so equals to y. So actually what we are getting, we have started from the pre-image and we have got one image here. This is the way, that is we have to do in reverse process of the 1 function. So here we can say that is the function fx equals to 3 minus 4x is onto. I am taking another example. Fx equals to x cube, where x is defined on, or okay, I am taking fx equals to 1 by x. X cube will be also there. Fx equals to 1 by x, where the function is defined on r0 to r0, where r0 is the real numbers excepting the 0, except the 0, that is it can be written as r minus the singleton 0 here. We have to check this is as onto function. How we will check? Just see the same process. We are taking y equals to 1 by x. So from here we are taking x equals to 1 by y. Actually we have to express the image at the terms of the pre-image. Here also the image at the terms of the pre-image we have done. Here also the same thing. X equals to 1 by y. Now y is non-zero real number. Those are two different functions. I am giving a border here. Y is non-zero real number, so obviously 1 by y is also a non-zero real number. Simple logic. Then we can say if x equals to y implies that f of 1 by y is equals to y. That means each and every y in the next that is the codomain, each and every y of the codomain must have one pre-image at the domain. So that's why we can say this is as also onto. So students, this is all about the onto functions. So I will say you to pause the video and jot it down. So relating to that previous discussion, this type of question comes at your exams. Check whether fx equals to 3 minus 4x is bijective. Note down the term, the bijective. Bijective means it is injective and surjective. That means it is 1 1 and on 2. Whatever the functions supports the conditions of 1 1 and on 2, or you can say injective and surjective, those functions are called bijective. So here 3 minus 4x, I have proved the bijective, proved the surjective there. Okay, I am doing the total answer here. For injective, to prove injective is very much easy. That is, let x1 not equals to x2, that means 4x1 not equals to 4x2, that means 3 minus 4x1 not equals to 3 minus 4x2, and that means f of x1 is not equals to f of x2. By analytical definition of the injective function, we can say that is the images, the pre-images are different, that's why the images are also different here. So it is injective. For surjective, we have done this just few minutes ago. I am just showing you fx equals to 3 minus 4x, then y equals to 3 minus 4x. From here x equals to 3 minus y by 4. So fx equals to 3 minus 4 into 3 minus y by 4 and equals to y. So from here we can say the function is surjective. So fx is bijective. This is the way to prove this one. For bijective, sometimes you will not be able to show directly this type of things, but logically you can say that one. Students, our next function is the into function. Actually, I have done a slight mistake there. That is, this function should be at first. Okay, whatever. Into function, from the name only you can see that one. The into function means the codomain of the function must have an element, at least one element that doesn't have a pre-image at domain. What we were discussing previously for the 1 1 and many to 1 function, for those two cases we have drawn the arrow diagram like that. That is, if we draw this arrow diagram like this, so just see here, two elements are there, this and this. Those doesn't have any pre-images at the codomain, at the domain here, that is the set A. So those type of sets are, those type of functions are called the into function. Actually what they want to say, that is the codomain must be the subset of the range. That is the proper subset of the range, not the equal to. Codomain will be the proper subset of range. Those type of functions are called the into functions. For this only the definition is sufficient. Sometimes you have to show that is the, this is the into, sometimes, not always. So we have discussed about all the types of the functions for those two videos. I think you can solve the examples related this one. I will give some homeworks now. You will try to solve those, and if any problem or any doubt, then you will ask me at the comments or at our personal WhatsApp group. So jot down the homeworks now. Students, those are your homeworks. Just jot it down, and also you will do those, and positively you will submit. Just take the pictures of the answers and show me at my personal WhatsApp group. Okay, this is all about the discussion of the types of the functions, and I think you have got all of these concepts. I will discuss about the composition of the functions and also the invertible functions, and some conditions are there, some results are there, and even and odd functions are some slightly some concepts are left there. I have forgotten to say that, those I will say, and then we will close this chapter. So students, today up to this. If those videos are informative to you, so please subscribe my channel, and also please give a like, and if you want, then you can give the dislike button is also for you, and please subscribe my channel. Thank you, students.